Today we're going to talk about how to quickly graph linear equations. There's two different methods we're going to talk about today. At least one of these is probably going to be familiar from Algebra 1, but maybe or maybe not the other one. So in our first lesson of this chapter, we talked about graphing and we made XY charts. So we picked out some X's and plugged them in, and that allowed us to find Y's. We then plotted those as points. That works. It'll work every time. And XY charts are a really good way to graph an equation, especially when you encounter a new type of equation. So when we first see our quadratic equations, we're going to go back to making charts. But it's kind of a lengthy process. So there is a shortcut that we can use, two different forms, two different shortcuts we can do here. The first one is for slope-intercept form. Slope-intercept form is the equation y equals mx plus b, where b is the y-intercept, or where the graph hits the y-axis. And that's really important to note because a lot of students make a mistake on that. That intercept is where it hits the y-axis, not the x-axis. The m value is the slope. So you talked a lot about slope yesterday. Slope graphically meaning a rise over a run, or being able to subtract the values of 2 points to be able to find that slope. When we graph in slope-intercept form, we have 3 steps. We're going to start by plotting our y-intercept, so putting a point on the y-axis at the value of b. Then we're going to count out our slope to find another point, rise over run, and we are always going to head towards the right because that's the way we read a graph. It's just like we read a book from left to right, so we're going to read across our graph in that direction, and then we're going to connect the dots. You only have to make 2 dots. You can keep making more. It helps me make a straighter line, so a lot of times I'll do more than just 2, but you really only need 2. So for this problem, we're going to start by putting a point on the y-axis at -2. That's our b value, or our y-intercept. So on the y-axis, I'm going to put a point at -2. Then, the 3/4 is our m, or our slope value. I don't know why it's m and b. You know, it seems like they could pick better letters like S for slope. I don't know. I don't know why they picked that. But m is our slope and b will be our intercept. So from our point that we already plotted, I want to count a rise over a run. Count up 3 and to the right 4. So I'm going to go up 1, 2, 3 points over 1, 2, 3, 4 points, and I get a new point. Okay, so from the y-intercept, count up 3, and then over to the right 4, and that gives us 2 points. And then we can connect the dots and get a line. That is very dark. I don't know. You should put arrows at the ends of your line because lines do go on forever. So even though we are only looking at one portion of it, we want to show that that line goes on forever. Okay? Questions?
Where often people have to use graph paper?
You do not have to use graph paper as long as you create yourself a grid and graph neatly. On the test, there will be little grids like this. So on the test, you'll be plotting it on graph paper. Okay, so for the next one, we're going to start by plotting our b value, which is +1 this time. So on the y-axis, I'm going to put a point at +1. Then our m value, which is our slope, is 1/2. So from the point we already plotted, not from the origin, but from the point we already plotted, we're going to go up 1 spot and over 2 spots. And that's really enough to be able to connect the dots and call this graph done. But I have trouble drawing a straight line when I only have 2 points to connect. So you can keep on doing this process. So from now this point, I can go up 1 and over 2 more. I can go up 1 and over 2 more, and I can continue that on out. You can also go backwards, and now that I can see the pattern of this line, I can see that I'm going to go down 1 and left 2, down 1 and left 2, down 1 and left 2. And I can get a lot of points to connect, which helps me make a straighter line. You don't have to, but I'm just not very good at drawing straight lines. Okay, and then arrows on the ends. Questions? Okay, so for this one, what is our b value? Our intercept value? -3. Always make sure you tie that negative to the number that follows it. So it's not just a 3, it's a -3. So at -3 on the y-axis, I'm going to put a point. And then our m value is 2, but that's a little bit of a problem because we need a rise over a run. So how can I write this as a fraction so it's a slope? 2 over 1. So I'm going to rise up 2 places and just go over 1 place. So if you have a whole number, just put it over 1, and that'll give you the run. So you go up 2 and over 1. Again, these are really close together, so I'm going to keep on making more points, up 2 over 1 again and again, just to get a lot of points to connect, but you don't have to. Questions? Okay, I want to actually do one more that's not in your notes. One thing that didn't come up in any of these that can and will come up is an example like y equals -2/5 of x plus 4. Okay, so in this equation, what is our intercept or b value?
4.
4. So I'm going to go up to +4 and put a dot. Then our slope value is -2/5, and that's what's different about this one is that it's negative. I always think about my graph heading to the right because when we read graphs and start to talk about their features, that's the way that we direct a graph, is like a book from left to right. So what I'm going to do with that negative is make it a fall. You learned yesterday that a negative slope is a falling slope. So instead of rising 2, I'm going to fall 2. But I'm still going to go to the right 5 spaces. Okay, so I always travel to the right, no matter what. But if I have a negative slope, that is a falling slope. So I fall instead of rise. Okay? Questions on that?
Well, he just had a negative x.
That would be like a -1x, so it'd be a slope of 1 over 1. Okay, there's always a coefficient of x, even if there's no coefficient written there. If it's just a plain x, it has a coefficient of 1.
So you just turn, like if you say you just start at 4, you just go down 1, right?
Yeah. Alright, so the other special form of the equation is the standard form. Standard form is ax plus by equals c. So the x and the y are on the same side of the equation. With our standard form, we're not only going to care about our y-intercept, but we're going to care about our x-intercept as well, which is where the graph is the x-axis. There's 2 different ways you could graph in standard form. I think there's a longer way and a shorter way. The longer way would be to solve this equation for y by getting y alone, which is a skill that we learned in the first chapter, how to get y alone. I think a better way is what I'm going to teach you is called the cover-up method. That's what I call it, where we're going to find our x-intercept and our y-intercept and connect those dots. The reason why I like this way better is I think it's a lot quicker. And there's a lot of opportunities to make mistakes if you're trying to solve for y. So we did that in the first chapter. I think it was like lesson 1-4, and it was just on your last test. And there's just a lot of things that can go wrong. While you're trying to get y alone, you can divide wrong, or you can lose a negative, and any of those things that can go wrong are now going to make you graph the wrong line. So what I like to do is called the cover-up method. And essentially what we're doing is saying first, let's let x equal 0. If x equals 0, I can cover up the part of the equation that has the x in it, because multiplying by 0 is just 0. So I can cover up that whole front part of the equation, and all I'm left with then is 3y equals 12. So what would y equal? 4. So I'm going to go to where y is 4, and I'm going to put a point. Okay, so I'm going to let x be 0 and just ignore the x part of the equation, figure out what y is, put a dot on y at that number. Then I'm going to do the opposite. I'm going to let y equal 0. Then I can cover up or ignore the y part of the equation, since it would just be 0, and I'm left with 2x equals 12. So what would x be?
6.
X would be 6. So then I'm going to go to where x is 6 on my x-axis and put a dot. And I have 2 dots, so I can connect them, and this is our line. Yes, it was mine. Okay? It works to solve for y. So if you're like, no, I think I'm just a really big fan of slope-intercept and I think I want to do that, that's absolutely fine. And in fact, some of your homework problems tonight do ask you to do that. They give you an equation in standard form and ask you, what is the slope? So you could graph it and then count out your slope. That's one option. Or you could solve for y. And then it would be in slope-intercept form, and we could find that. So I'm going to review that process with you here on this one. I'll tell you this, it's not the way that I usually do it. I just feel like there's too many places to make a mistake. So if I want to get y alone, what's the first thing I need to do? Subtract the 2x from both sides. So then I get 3y is negative 2x plus 12. We can't combine those because one has an x and one doesn't. So we can't just like make it 10x. Okay. Then I'm trying to get y alone, so then what do I need to do?
Divide each individual thing by 3.
Divide each individual term by 3. So that gives me y, negative 2/3 x plus 4. If we think about plotting that equation then in slope-intercept form, it would have a y-intercept of 4. So I get a point right here, that's good. And then it would have a slope of down 2 and over 3. So I go down 2 and over 3 and I get a point. Down 2 and over 3 again, and I get the other intercept point. So we get exactly the same line either way. I think it's a little bit longer and a little bit more dangerous of a process to do it this way, but if you're like, I think I can only handle learning one way, that's totally fine. And then you just know your one way of doing it in slope-intercept form. Questions? Okay, so for this one, if we do apply the cover-up method on it, I'm going to start by letting x equal 0. And I can cover up the x part of the equation, which leaves negative 2y equals 6. Don't lose your negatives. Remember to tie a negative to the number that follows it. So it's a negative 2y equals 6. So y equals negative 3. So on my y-axis, I'm going to put a point at negative 3. Then I'm going to do the opposite thing. I'm going to let y equal 0 and cover up or ignore the y part of the equation. So I get 3x equals 6. So what does x equal?
2.
That gives me 2 points. And I can connect the dots. Questions? One more like this. Start by setting x equal to 0, which lets us cover up or ignore the x part of the equation, and gives us a y value of 3. Then let y have a turn to be 0. Cover up or ignore that. 6x is 12, so x is 2. Our x-axis put a point at 2. So connect dots. Questions on standard form? One situation where the standard form cover-up method is not going to work for you is if you have something like 2x plus 3y equals 0. Because then, if I let x equal 0, then I would have 3y equals 0 and get y equals 0. Well, x is 0, y is 0 is the origin, and so that's only 1 point, and you need 2 points to be able to connect the dots. So if you have it in standard form but it's equal to 0, you're going to have to solve for y and do slope-intercept form. Because the slope, or the x-intercept and the y-intercept are actually going to be the same. They're both going to be the origin. So that's not going to work out for you there. Okay? So that's one special case where you can't do your cover-up method because you'll only get 1 point. Okay? Horizontal and vertical lines, a lot of students get confused because we get used to our y-axis being the vertical axis. So then when students get a y-equals equation, they start to think it should be like the y-axis and be vertical. But y equals a number means that y is always that number. And if we start plotting stuff out, we'll end up with a horizontal line. And x equals is a vertical line. Okay? We can see this by making a chart. So I'm going to start with the y equals one. So if I made a chart, an xy chart for that, I can pick whatever I want for my x's. Well, if I plug a -1 in for x, well, there's no x's in there. It just tells me y is -3. So that means y is -3. Y is -3 no matter what x is. So if I start plotting those, I get points down at a height of 3 no matter what number I plug in for x. And so I get a horizontal line then. Okay, a y equals will graph a horizontal line because it has to cross the y-axis. It's giving us a value that y always is, so it has to hit the y-axis at that number, which is going to make it horizontal.
So the question's always like formed like that, or they give you the x equals and y equals, it's gonna be.
It's 2 separate problems.
Oh.
So we're just going to graph them on the same one to save a graph grid, but it's 2 completely separate problems.
Okay.
It'd either be an x equals a number or a y equals a number. So if x equals 2, that means no matter what y is, so no matter what height I'm at, I should always be over 2 spaces. So no matter what, if I go over 2 spaces and then connect all those points, I'm going to end up with a vertical line. So a y equals has to cross the y-axis, which is going to make it horizontal. And an x equals has to cross the x-axis, which is going to make it vertical. Okay?
I wish they would.
Questions? Right, your homework is from lesson 2.3 tonight.